Hey everybody, welcome to video 3 for Cumulative Review Packet number 6. We were working on number 13, and what we did so far was we found the inverse algebraically by switching x and y and resolving for y. And then I took -2, -1, 0, 1, 2, and I plugged these x values into this function to get these y values. And where we left off is how we're going to get from here to actually graphing the log function. Now remember that logs and exponents are inverses, which means that the table can also be reversed. So if I write this a little bit more neatly here, a little bit more room, if I would like to find the table for the logarithmic equation, I can just switch my x and y's because that's what I did to find the inverse in the first place. So this point down here would become 14, 2. This would become 2, 1, -1, 0, -1.75, -1, and then almost -2, but -1.9375, -2. And if I plot all of these points, I should get my logarithmic equation. -1.935, -2 is almost -2, -2, very close. -1.75, -1, -1, 0, 2, 1, and then 14, 2. Let's just do the best we can. 14, 2, probably around here. So just to go back to something really quickly, I want to point out to you that on the previous example, number 12, that when we had an exponential equation, I had a horizontal asymptote, or a line I can't cross. Because a logarithm is an inverse, I'm not going to have a horizontal asymptote, I'm going to have a vertical one. And it looks like my graph, if I connect the dots here, is going to get close here to -2, but not quite get there. So it looks like this time my line I can't cross is not horizontal, but instead vertical, which makes sense with the inverse idea. Which means the line I can't cross is now x equals -2, because it crosses the x-axis here. My domain of my function looks like it starts at -2 and then goes to infinity. So my domain would be -2 to infinity, not including -2. The range is the inverse of an exponential. So the range is going to be -infinity to +infinity, which is again the opposite of most things we've been doing. And then my intercepts this time, it looks like I do have both as a possibility. I do have a x-intercept right here. So my x-intercept is at -1, 0. And if I want to find my y-intercept, remember, you could look at the graph, but it's not exactly accurate. So if I want to find my y-intercept, that's when x equals 0. So because my original function was log base 4 of x plus 2, we're really finding log base 4. If I plug 0 in here, log base 4 of 2. And we can do this without a calculator. Remember, this means 4 to the what is 2, because logs are exponents. Well, how do I get from 4 to 2? Well, I know that the square root of 4 is 2, which means that 4 to the 1/2 must equal 2. So the exponent that I'm looking for is 1/2, which means that the y value I'm looking for is 1/2. So my y-intercept would be at 0, 1/2. And if I look at my graph, that seems pretty reasonable. Looks like it might cross at around 1/2. And again, that's because when I look at log base 4 of 2, I know that 4 to the 1/2 is equal to 2. So there's my graph, and here's my information about the problem. Number 14. $2,750 is invested at a rate of 6% compounded monthly. What is the balance at the end of 7 years? Well, monthly, everything is in terms of years. Monthly is 12 times a year. And so in this case, the end value would be 12. So if I'd like to find my balance at the end of 7 years, I'm going to use this compound interest formula. Y equals P times 1 plus R over N to the NT. P is my principal value. My y is my output, so it'll be 2,750, 1 plus my rate. Now remember that this 6% is really 0.06 as a regular number, So it'd be 0.06 over the number of times the money is compounded, 12 times, to the 12 times 7. So to simplify that, that'd be y equals $2,750, 1 plus 0.06 over 12 to the 84th power. Now, as a suggestion to you, when you're plugging it into your calculator, what I would do first is I would, in this order, because a lot of things get messed up with parentheses in your calculator, I would do 0.06 divided by 12 first, and feel free to do this with me. Then I would add 1, and please don't take anything out of your calculator. Then I would raise all of that to the 84th power, and then I would multiply by 2,750. So let me repeat that. You would take 0.06 divided by 12, press enter. Without erasing it, press +1. Without erasing it, press the little caret key and raise it to the 84th power. And then multiply everything you already have that should be in your calculator times 2,750. And if you do, your answer should be $4,181.02. If you did not get that, please go back and try it again until you do. The next question is, how much more money would you earn if your account was compounded continuously? So not just daily, not weekly, not monthly, not semi-annually, continuously. So the equation to find something continuously is y equals p e to the rt, pert. Now this one, everything is based on e. And remember, e comes from finding a limit approaching a certain value. So this time, my principal value is still 2,750, but the calculation's a little easier because it's e to the rate 0.06 times the time, 7 years. So in your calculator, you would take e to the 0.06 times 7, and then multiply that by 2,750. When you do so, I got this value to be $4,185.39. So if it's asking how much more, you're going to take the $4,185.39 and you're going to subtract $4,181.02, getting you a grand difference of $4.37. Last part, solving equations. Exact answers only, please. No decimals unless specified. So number 15, I notice that I have an exponent equaling a number. The first thing you want to possibly do without introducing logs is see if you can change the base. So I notice that, that's an S there, I notice that 64 can be written in terms of the base of 4. So this could be 4 to the 2x equals 4 to the third, because 4 times 4 times 4 is 64. And as soon as you have the same base, the exponents must be equal. So 2x would equal 3. So if I left my answer exact, x would be 3/2. Number 16 is similar in logic. And yes, because you do have exponents on both, or an exponent, you could apply logs to both sides, but again, it is good to check to see if you can change the base first. So I look at the base of 3 and ask myself, can 81 be written as 3 to the something? Yes, it can. This can be written as 3 to the 4th. So 3 to the 4x plus 1 is equal to 3 to the 4th. So just like number 15, if the bases are the same, I know that the exponents must be equal. So 4x plus 1 must equal 4. 4x must equal 3. So my exact answer would be x equals 3/4. Number 17. When you look at this one, again, when you think about 8 and 32, it's tempting to say that you cannot rewrite 32 in terms of 8. But what you could do is think about a smaller number that you could rewrite as both of these. My mind goes to 2, actually, because 8 is really 2 to the third, and the 6x plus 2 is already up there. So we'd have to multiply 3 by 2x plus 2. And then when I look at 32, I notice that 32 could be written as 2 to the 5th, because 2 times 2 times 2 times 2 5 times is 32. So now again, my bases match, so I know that this piece must equal this piece, or 3 times 6x plus 2 is equal to 5. 18x plus 6 equals 5. Subtract the 6 over. 18x equals negative 1. So I get a lovely answer of negative 1/18. So the moral of the story so far is if you see exponents, see first before applying any kind of log if you can change the base or manipulate it in a way that you can get the two exponents to be equivalent. The reason I mention this is because if I transition to number 18, the first thing I want to do is try to get the exponent alone. So I would get 3 out of there, so you just have 7 to the x. So then you'd have 7 to the x equals 39 divided by 3, which would just be 13. Now, unlike the previous 3 examples, when I look at the base of 7 and 13, there's no way I can get 7 to the anything to be 13 or 13 to the anything to be 7. So I'm stuck. Until I notice that I can apply logs on both sides of this equation. You could apply log or ln. It's based on you completely. Because my base is not e, I'm going to go ahead and apply logs on both sides. So log of 7 to the x equals log of 13. When I apply a log on both sides, my exponent comes in front. So I have x times the logs of 7 equals the log of 13. If I want to get x alone, I divide both sides by the log of 7. So my answer in exact form would be log of 13 over log of 7. And both of these logs are base 10. And this is somewhat the change of base formula here. And this is again how a calculator used to be able to calculate before they got more sophisticated. If you would like to round to the nearest thousandth, if in your calculator you just take the log of 13 divided by the log of 7, that would be x equals 1.318. But again, this would be accepted on a test because it is exact. So if you have exponents, see if you can change the base first. If not, you can apply logs on both sides and have the exponents carry down. For 19, it looks like I'm not given exponents this time, I'm given logs. But if you're ever not sure what to do with a log, think of it as an exponent. Because I'm sure, as you know, that I've been saying the whole video logs are exponents, which means that the negative 2 is my exponent. So what I could do is convert this. I know that the base is 8. I know that the exponent is negative 2, and that must equal x. So in other words, negative exponents are reciprocals, so x would really be 1 over 8 squared, or 1/64. In the same way, my last problem, number 20, ln of x equals 8. Whenever I see ln, I assume it's really a hidden base e. Kind of like here, it's really a log base 10 hidden there. If I see a log or an ln and I don't know what to do, let me convert it to an exponent so I know maybe how to attempt it. The base of this problem is e. Logs are exponents. My exponent is 8, and that must equal x. Honestly, you can just leave your answer as e to the 8th, because e is just a number, and the decimal will be quite annoying. So let's just leave it exact as e to the 8th. Guys, remember you can go back and rewatch any part of this video or the previous 3 if you need it. Thank you for your attention, and I hope these videos were useful to you. Good luck on your test.